Raise your hand. I just want kind of idea. Okay. I'm going to just come by and see what you've got. So GCF, breakup. Okay, we'll talk about it. I think there might be an issue there. Just kind of run through it again. Who else said they were done? Where are you at? Okay, you're not quite there. You still got a little bit to do. Same with you. You got a little bit more to do.
Kind of close?
Kind of close. Mm-hmm. What did you do here?
Well, I did that.
The grouping?
Yeah.
Okay, run through that again. I think you have an issue with that.
Oh, I see.
Yeah. You see. Okay, so what is the first step for factoring? I mean, you're good. This should be a plus because you pulled a negative out, right? See how they're both negative? So if you pull a negative out, then look at, if you multiply that back through, it'll be negative. That's okay. But when you multiply negative times negative, it'll be positive. Okay. So make that positive. And then these two things match, you see? Yeah. And then you can pull that out.
Okay.
Who else has done? Let me see. I haven't seen anyone have the complete. You're close. You're close. You're close. This is kind of a tricky one. Oh, you're real close too. You got one more thing to look at there.
Oh. Sir?
Yes?
So would it be like x x squared?
In parentheses. And then you're still almost there. You're not quite. There we go. Okay. Got one there. Okay, let's run through this, all right? Because I saw a lot of people on the right track, but then I saw, kind of people veering off in different places. So I'm going to follow the process, and I noticed that a few of you did not follow the process, which is okay. You can still do the problem, but later on your answer is going to look different, and you'll still have additional work to do. So what is the first step? Greatest common factor. That's the first step. So do all these have something in common? X squared. You want to pull the x squared out first. All right? So that x squared comes out. And enough space here for how many terms? 4, right? Because I'm pulling out from 1, 2, 3, 4 terms, so I need a space for 4. All right, so what would I have left inside that parentheses? X cubed plus 3x squared minus x minus 3. Okay, so that's what would happen if I pull a GCF out first. Now what I'm supposed to do is look at what's in the parentheses and count the terms. How many terms do I have? I have 4 terms. So I'm now supposed to do, right, 1, 2, 3, 4 terms. I'm supposed to do grouping on this. So I'm actually going to do that on the side so that I don't get confused. I'm going to do this on the side. I'm going to slash it right there. And I'm going to pull a GCF out of these. What's a GCF out of those two? X squared. What do I be left with here? X plus 3. Okay, now I've got to pull something out of here. What do I pull out of these two? I'm going to pull a minus 1, a negative 1. And then what would be left in here? X plus 3 again. See how that works? Now these both have x plus 3, don't they? So I can pull that out. And that will be x plus 3. And what goes in that next parentheses? X squared minus 1. Okay, so that's the grouping, right? Y'all see that? But we're still not done. Because look at this one right here. What is this? That's a difference of squares. Isn't it? That's a difference of squares. So like on yours, you had, and some other people had this also. had gotten to a piece where it was like this. See, the problem is the GCF didn't come out in the beginning. So if you forgot to do that earlier, then when you get to this, you actually have to pull your GCF out now and then do difference of squares here. So if you do the GCF in the front side of the problem, then you don't run into that trouble later. Now I'm not done. Hold on, let me finish. I've got x plus 3 here, right? Difference of squares, this becomes x plus 1, x minus 1. We've talked about that. Y'all seemed okay with that. That's what this is, right? Okay, so I come back over here and I say, all right, x squared, right? And then times, where is it? This one right here, this right here. So x plus 3, x plus 1, x minus 1. Question?
How come you didn't group the x squared with this x squared over on the left side? So where your first equal sign is, that one right there? So you know how you took the group of 4 and you
Yep.
moved it over?
Yep.
And then we got an x squared when we got the GCF of that one.
Uh-huh.
That one, that x squared and that x squared don't group together.
Okay, good question. So think about it this way. When we pull the GCF out, right, this thing right here distributes through to everything, right? Okay, so if it's sitting out here, all I'm doing over there is saying, what's another way of rewriting this, right? So if I go through the process, I'm going to rewrite this piece in parentheses like this, which becomes this, and here's the x squared. I think your question is, why didn't I incorporate this x squared in with this x squared, right? Is that your question? It's because all of this lives in a parentheses, right? It lives in this parentheses right here. So that x squared is not allowed to just mingle with one little piece of this. It has to mingle with the whole thing, right? Does that make sense that way? So you can't combine it with this one at all unless you're willing to put the x squared through everything, which is what we kind of undid in the very beginning, right? We pulled the x squared out of everything to make this part, the factoring on this, easier. I hope that addresses your question. Okay. All right. So this is a good problem. It had GCF, it had grouping, it had a difference of squares all in one problem, right? Any additional questions on that? Okay, this next one's going to look weird. I don't know if it'll look weird, but I think it's going to be weird. A cubed plus 8a. So factor that. I'm using a instead of x, all right? Using a instead of x. So what would be our first step? GCF, which is a. What would be left inside? Plus 8, right? Can you do anything with the a squared plus 8? You can't, right? It's a sum, right? Now 8 is a cube, isn't it? But a is not a cube. This is not a sum of cubes. Therefore, it does not break down any further. All right, so we'd be done at this point. Now, the reason I brought this up is because if you do a problem on your homework, or if you see something everywhere, it's like, you know, factor, let's say x squared plus 8, and it says factor this. What is your answer? I mean, you can't do anything to it, right? The way that I believe the solution manual will say this is they will say prime. In the answer, it'll say prime. And that just means that it can't be factored. All right, so I just wanted you to see that language. Where does the idea of prime come from? Have y'all heard of prime numbers? What are the prime numbers? Can you explain what a prime number is to me? A number that's what? Doesn't have a square. Think about numbers like, let's look at like 15, 12, 9. Look at these numbers. Are these numbers prime? No, the reason they're not prime is because they can always be broken down as two numbers that can multiply to be that number. So like 3 times 5, right? Here you could what? 3 times 4 or 6 times 2? It doesn't matter, but the thing is, you can break it down, right? 9 is what, 3 times 3? So these are what we call composite numbers because you can make them by multiplying smaller numbers to create those numbers. An example of a prime number is 7. 7 is prime because there's no way to tree it out like this other than to use 1 and 7. And 7 is 7, so it doesn't break down, right? So we're about to take a break, but I'm really doing a good job with useless information this semester. This one is actually very useful. This one is useful. All right, so you know everyone here uses email and bank. You probably use your phone or your computer at home for bank stuff, right? And they'll say like certain things are encrypted, right? Like I know Apple is real big on encrypting their phones, right? Even the NSA, the FBI has asked Apple to please not use that encryption because they can't get into the phones, right? The most standard form of encryption, I'm trying not to go way off on a tangent here. Do y'all know what encryption is? I already feel myself going off. You know what encryption is? Just think of it this way. For as long as humans have been around, we've wanted to communicate messages to one another without letting other people know what the message is, right? There were smoke signals, there's all sorts of things that we've done throughout history. But how do you do it electronically, right? How can you send something electronically safely? So one of the most simple ideas of encryption is this. You take the alphabet, right, blah, 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 all the letters, and instead of writing letters, you put numbers. Okay, so if I wanted to send you a message, I would write, let's say, 4414. What's that message? Dad, right? Dad, whatever. So that's a form of encryption. What I'm doing is I am assigning to each letter some special number or something. But I think this would be pretty easy to break, right? Someone would eventually figure that out. So I could do something different. I could maybe I could start this at 9 and then 10 and then 11 and 12. And then now my message is 12, 9, 12. And it won't be as easy to figure out that that's Dad, right? So that's better maybe, right? But it's still, this is weak, very weak encryption. So what does this have to do with this? It actually has to do with this idea of prime. There's been a battle that's been taking place for as long as humans have been around with the people who are trying to do the encrypting and the people who are trying to break the encryption, okay? And it's been a battle. If you know anything about World War II, does anyone know about the machine the Germans used called the Enigma? Yeah. It was like a typewriter, basically, and they would type in, it had gears, and it was basically what's called a polyalphabetic encryption, where every letter was on its own like cipher. It was crazy, but it had a weakness. The weakness of it was that in a message, they used letters. In a message like, you could have a message like this, okay? And these two Fs are in their encryption system with the Enigma would not represent the same thing. So like this F is different than this F. It's a very powerful machine, but it had a weakness in that in the encryption, if I wanted to send the letter X, right? If I wanted to send the letter X to you, I could never use X in my encryption. Like X could never go to itself. And that's how we broke it. We actually used that flaw. So, okay, the most powerful form of encryption right now is by all means, it's unbreakable. We have not figured out a way to break it, and it has to do with prime numbers. All right, so let me give you an example. I'm gonna come over here, and this is me. Do y'all want to hear this? Okay. This is me, this is you. All right? And this is the world. All right? All right. So this is the world. And imagine y'all are sitting over here. I'm sitting over here, and I want to get a message to you, or I want you to send me a message. All right? So here's what I'm going to do. I come over here, and I come up with two prime numbers, right? So I'm going to take two prime numbers. 3 is a prime, and 7 is a prime. I'm going to multiply them together. That's going to give me 21, okay? So what I do is I tell everyone 21, all right? And so what you do is with your message, you use that 21. Let's not get into the details of how this happens, but you use that 21 to scramble your message, okay? So you use that number to somehow scramble what you want to tell me. And you come over here and you scramble it, and then you yell it to me. And when you yell it to me, it's like, ah, nobody understands what you're saying. It's scrambled up, right? And even these people over here, they know the number's 21, but they don't know, all they hear is you screaming out this scrambled, garbled stuff, right? The only way to break that scrambled stuff, the only way to break it, is to know that 3 and 7 were the prime numbers that I used, okay? Does that kind of make sense? Now, 21 is a small prime number. So this wouldn't work. So what we do in the real world is we take prime numbers that are like 40 digits long. Okay, so you'll take a prime number that's 40 digits long, huge number, and you'll multiply it times another 40-digit prime number. You'll have an 80-digit prime number, and that's what's screamed out to everyone. And so now I send my message, it's scrambled up. Everyone can see my scrambled message, but the only way to break it is to know what those two 40-digit primes were. All right? If you had every computer on the planet trying to figure out those two primes, it should take the age of the universe for that to happen, which means that it won't happen. And the thing that's so powerful about it is that as computers get faster, we just go with bigger numbers. So if you eventually will go up to 50-digit primes, and there's an unlimited number of primes. So this is called Rsa Encryption, and it's for the 3 gentlemen who came up with it. They actually kind of stole it, but that's not important. And this encryption it's pretty simple, but I haven't done any research on it lately. But back when I was reading about this, it's just a program. It's just an algorithm that a computer can run. And if you put it on like a flash drive, if you had that program on like a flash drive or a disk or something, and you try to leave the country with it, it was considered exporting a munition by the FBI and stuff. Anyway, okay, so that's why when you hear about terrorists and stuff that are using encryption, you're like, oh, I'm sure our NSA can break it. I'm sure that, nope, it's not happening. There are ways to encrypt things that cannot be broken. So the encryptors have the advantage right now. So if you want to either become very wealthy or very dead, you figure out how to break RSA encryption, because if you can break it, you're going to bring all the financial markets down. Everything comes to a halt because you can't encrypt anything anymore, right? So you either become very wealthy with that knowledge or you become very dead or missing, right? So people have been working on this for a long time. No one's figured out a way to do it. But it's a very simple idea, right? 2 primes, create a composite number. If you can get that composite back to here quickly without having computers needing to do it for billions and billions of years to find it, then you're in business. Yeah. Don't tell anyone, all right? Don't tell anyone. All right, let's take our break. Come back at 12:30, and we will start with 3 terms. I'll pass the sign-in sheet around now, and then other people. I know you said you had a doctor's appointment.